SPSS class. Today we are going to see properties of relationship between the variables. Till the classes we already know what are the variables and its types, we know all the things. Today we are going to see what are the properties of the relationship between the variable. I am Professor Ramraj. Today we are going to see the positive and negative relationship. Two or more variables may have a positive or negative or no relationship at all. In a case of two variables, a positive relationship is one in which both variables vary in same direction. For example, if two variables are moving towards the same directions, however, when they vary in the opposite direction, they are called a negative relationship. If two variables going in the straight or the same direction, that's called positive. If it is in the opposite way, that is called negative. If one variable in the positive and another one will be in the negative, that is called inverse variable. When a change in other variable does not accompany the change or movement of one variable, it's the variable in questions are unrelated. For example, if an increase in a wage rate accompanies in the one job experience, the relationship between job experience and wage rate is positive. For example, if a person working in a company for more than 10 years, the person earning some 50,000 or 60,000. If a person working the same job for the 1 year, the person might get 20,000 or 30,000. So the age and the experience having a huge impact on the positive relationship. If an increase in the level of education of an individual decreases desire for the additional children, the relationship is a negative or inverse. There is a kind of controversial one. But a person in the olden days, the people does not having the much knowledge and aware about the education, they are having 5 or 10 or 16 kids they have. But now we are more educated, we are having 1 or 2. So that's kind of the negative or say inverse relationship also. If the level of education does not having any bearing on the desire, we say that variable desire, additional children and education are unrelated. If there is no relationship between, that's called unrelated one. So the next one, strength of the relation. How much the relationship having the strength. Once it has been established, two variable are indeed relations. First we have to confirm whether there is a positive, whether there is a relation. Then we have to know, we want to ascertain how strongly they are related. A common statistics to measure the strength of relationship, so called correlation coefficient. It's symbolized R. R is a unit free measure. It's lying between -1 to +1 with a 0 signifying no linear relationship. So for the predictions of one variable from knowledge of other variable is concerned, a value R +1 means 100% accuracy in the predicting positive between two variables, and a value R -1 it means 100% accuracy in predicting negative relationship between two variables. For example, the person practicing more, the person possible to win the running race or whatever the exam, everything will be positive one. If the person is not at all studying anything, that person definitely they might the loss in that. That is also there is a relationship between that one. So positive extreme 100%, negative extreme 100%. Then the third one is called symmetrical relationship. We have been discussing only symmetrical relationship in which changing other variable accompanying changing the either variable. If one variable is changing, automatically the another variable also change. This relationship does not indicate which variable independent variable, in which variable is the dependent variable. In other words, you can label either variable as an independent variable. Such a relationship is a symmetrical relationship. In asymmetric relationship, a changing variable x are combined by the changing variable y, but not vice versa. The amount of rainfall, for the example, will increase the productivity, but productivity will not affect the rainfall. If I am having a paddy field, I should say, okay, this year we have lot of rain, so we will get a much benefits. I should not say I am having much benefit, that's the reason the rainfall. So we have to say x is a cause of y, but y does not cause for the x. So that is a symmetrical relationship. I can go and comb my hair in front of mirror, but mirror should not comb my hair, myself it will be reflecting. That is called the symmetrical relationship. So I hope you understood. Similarly, the relationship between smoking and lung cancer would be asymmetric because smoking could cause cancer, but lung cancer it's not only for the smoking. There are any other reasons also there. So the next is a causal relationship. It's indicating the relationship between two variables does not automatically ensure the change in one variable causing the another variable. While no one can ever be certain that variable A cause variable B to occur, nevertheless one gathers some evidence increase the belief A leads to B in attempt to do so. So we seek the following evidence. Number one is the relationship between A and B. When such evidence exists, it indicates possible causal link between that variable. Second is the relationship between asymmetric, the change in a result A in change in result B, not vice versa. In other words, does A occur before B? If we find that B occur before A, we can little confident that A cause. We have to notice that. Does the change in A result in the change of B regardless in the action of other factors? Or other words, is it possible to eliminate other possible cause of B? Can one determine that C, D and E say do not co-vary with a B, we suggest a possible cause. For example, hot weather it will cause melting of ice cream. Hot weather it's a hot bulb or something. So there is a correlation. Because of the sunlight we feeling hot. Because of the sunlight the ice is melt. So there is a correlation between that variable. Then the next one, linear and non-linear relationship. Linear relationship is a straight line relationship between two variables. You can see in the graph itself whether the variable vary at the same rate of regardless whether the value high or low. It starts from the same one, it's horizontally it will increasing, and this is in the slope formation. This is the contrast with the non-linear. It will be a relationship whether the rate which one variable change in value may different or different values in the second variable. Whether variable in the linear related to the other variable or not can simply be ascertained by plotting x values against the k values against the x values. If the values when plotted appear in the line, the straight line, the existence of linear relationship between x and y suggested. Height and weight almost always approximately in the linear, while age and fertility rate it's a non-linear relationship. If a person having a 1 age or 2 age and the height, it might be the same weight. For example, 3 years kid, the weight and height might be same one. 10 years kid, the weight and height might be almost similar, but it should not be in the non-linear. It will be a curved nature. So these are the relationship we are seeing together. So next class we are going to see level of measurements or scales of measurements. Will continue in the next sessions. Thank you.